Today we are playing around with square matrices and their diagonals. We are playing around with triangular matrices. We are learning about the contour of a matrix. And then we work on calculating the transpose and then the determinant of a matrix. Hello world, and we are dealing with mathematics and matrices on episode number 45 of Versus Codewars. And I hope everyone is having a wonderful and safe day today. We begin our warm-up segment with a kata that calls for us to return the nth index in a sequence of even numbers. We start with index 1, which is 0, and then we have index 3, which is 4, and so on and so forth. Let's go ahead and get started with this one here. Const nth even, and we will have our index right here. And what we will do with that index is, because we know the first sequence index in the sequence will be 0, the second index will be 2, the third index will be 4, the number index 100 is 198, and so on and so forth. What we can actually do here, I see a pattern right here that we can take advantage of. And that pattern is, we take that index and we multiply that by 2. And then we take the product and subtract 2 from that. Let's go ahead and test this out here. Console.log nth even. Let's do 100 here for example here. And let's go ahead and run this in our terminal to see what this looks like here. Warm up node, warm up nth even number. And we get 198. Let's try this large index right here and see what this looks like. And we get the number 2,597,466. Alright, let's go ahead and punch this into Codewars to see what this looks like. Let's go ahead and hit test. And let's go ahead and hit attempt. And we are good. For our next warm-up kata, we are dealing with the powers of 2. We have to complete a function that takes a non-negative integer n as an input and returns as an output an array of all of the powers of 2 with the exponent ranging from 0 to n inclusive. Let's go ahead and give this one a try here. Const powers of 2, and we're going to have our number right here. And what we are going to go ahead and do is, alright, we're going to keep track of our result array right here, and we're going to return it here. And we are going to go ahead and we're going to do for let I equal 0, I is less than or equal to number, because this is n inclusive, and then plus plus I. And then what we're going to do is we're going to do results.push, and we are going to do 2 to the power of I here. Now, this double asterisk here in JavaScript will basically tell JavaScript to take the number on the left-hand side, the base, and raise it to the power of the number on the right-hand side, this I right here. Let's go ahead and test this out here. Console.log powers of 2. And we're going to pass in 2 here, for instance. Alright, so clear this terminal here. We're going to do node warmup power 2. And we get an array with all of the numbers, the results of our exponents here. A list of all the powers of 2 with the exponent ranging from 0 to n inclusive. Alright, let's go ahead and punch this into Codewars to see what this looks like here. Let's run the test here. Whoops. Let's run the test here. And let's hit attempt. We are good on that one. For our next warm-up kata, we are dealing with the sum of triangular numbers. The goal of this kata is to return the sum of triangular numbers up to and including the nth triangular number. A triangular number is any of the series of numbers 1, 3, 6, 10, 15, etc. obtained by continued summation of the natural numbers 1, 2, 3, 4, 5, etc. Alright, let's go ahead and give this one a go here. Let me scroll down here. Const sum angular, numbers. We'll pass in our nth index right here. Then what we'll go ahead and do, well, first let's handle an edge case here. If nth is less than 0, then we have to return 0 here. Now, what we will go ahead and do is we'll keep track of a result here. And we'll keep track of a summation as well. Let summation equals 1. Now, what we'll go ahead and do is, for let I equals 0, I is less than nth, I believe, plus I here. We will go ahead and do result plus equals summation plus. Now, what, if I'm not mistaken, this is going to do is, this is going to take our result, add the current value of our summation variable here to that result. And then after that, increment this summation variable by 1 for the next iteration of this loop. Now, we'll go ahead and return our result right here. Let's go ahead and test this one out here. Clear the terminal here. I'm going to do node warmup some triangular numbers. I'm going to do a console.log down here first. Console.log some triangular numbers. We're going to pass in, I think 4 is a good number. Let's go ahead and run that, and we get to 10, and that is not what we want to see here, because I think this actually needs to be inclusive. So, and that is actually not what we want to see either. Okay, let's go ahead and console.log our result here.
136.
Okay, I might have to rethink this one here. Alright, we'll still have a result right here. But I think we'll set it to 1 instead. So, what we'll go ahead and do, or maybe 0. Yeah, okay. Maybe less than 0 here. 1, 3, 6, 10. And we'll go ahead and let our summation here equal 2. Then I think we'll go ahead and do our for loop here. So for let I equals 0, I is less than nth, then plus I here. First, I think we'll go ahead and do a console.log here, result and summation plus here. Two, 3, 4, 5. So, I think we'll take our results, add to it the summation plus here, and then we'll go ahead and return the result down here. And that is not giving us the desired result. And we need to figure out why. Maybe we're... Maybe we gotta set this maybe to 0 then. I'm not sure that's necessarily right. Let's have a look at some of the tests here. Let's try 943 here. Yeah, I figured that wouldn't be right. Let's try 34. Maybe given 4. Oh, yeah, I think I am approaching this entirely the wrong way here. Okay. One, 3, 6, 10, 15. Alright, we'll go ahead and keep track of a result here. We'll go ahead and keep track of a sequence number here. I think we'll start it at 1. And then we'll go ahead and keep track of a summation here. And I think we'll also set that... I think we might need to set that to 2, actually. So, what we'll go ahead and do for let I equals 0, I is less than nth, plus I. And we'll do sequence num... I think we'll set the result of 1 here. Anyway, we'll do sequence number plus equals summation plus, and then we'll set a result and add to that the sequence number here. And we'll see what that looks like here. 7,770, which is still not what we want to see. How about, what if we tried sending this to 1? And we get the right number, 7140. Alright, let's try some of our other test numbers here. Passing in 6 gives us 56. Passing in 943 gives us, I think that looks like 140,205,240. Alright, I think we are ready now to punch this into Codewars to see what this looks like here. Let's hit attempt. And we are good on that. For our next warm-up kata, we are doing addition the wrong way here. Allow me to explain. For this kata, we'll have to forget how to add 2 numbers. It's going to be best explained with this picture that you see right here. I'm going to go ahead and expand that out to full screen here. If it will load. Like this picture right here of this little girl trying to do addition right here. Anyway, I digress. Anyway, the goal of this kata is to add 2 numbers such that we add each individual digits of the numbers together instead of the numbers themselves. So given 16 plus 18, we first have to do 6 plus 8, which gives us 14, and then 1 plus 1, which would be 2. So we'd have to do 214 for the false sum here. For lack of a better explanation here. Alright, let's go ahead and get started with this one here. Silly addition. I see the test calls it here. Oh, Let's do add num1 and num2 here. Oops. Num1 and num2 here. And what we will go ahead and do is we will need the individual digits of these two numbers here. So what we'll do, I think we'll do const num1 digits and num1. Let's call it. I think these would better be known as first and second here. First digits, we'll set that equal to. Must see some here. Yeah, this will need to be a string first. So first dot toString, we'll split that into its individual characters here, and then map those characters out to digits here. And we will repeat that with the second number here as well. Now, what we will go ahead and do is I think first we need to determine which of these two numbers has more digits. So const max digits, or rather const max digits. I think we'll set that equal to math.max first digits dot length and second digits dot length, and then if I think we'll go ahead and do and then I think we'll go ahead and iterate over these digits here. I think we'll do for let I equal 0, I is less than max digits plus I. And then I think we'll go ahead and keep track of a result array here as well. So what we will go ahead and do, I think we probably will want these reversed as well. So I'm going to do that up here as well. What we are going to go ahead and do is, I think, if first digits dot length is equal to max digits, I think what we'll do is results dot unshift, because we probably will want to insert this into the start of the array here. No, I think we want to push it instead. We'll do first digits at index 0 plus second digits at index 0. No, I don't think that's going to work. We might need to reconsider this, actually. So, what we'll go ahead and do... I'm going to go ahead and get rid of all this here. And what we're going to go ahead and do... How about we go ahead and keep track of min digits and max digits up here. And then, if... Then we want... Const first string... First... Or rather, first chars... equals first.toString, and then const second chars equals second.toString. And then what we'll go ahead and do, if first chars dot length is greater than or equal to second chars, we'll go ahead and do max digits and set that equal to first chars dot map char parse int char, and then min digits set that equal to second chars dot map, and we'll do the same with that. Otherwise, we'll go ahead and do the opposite here. Replace second with first second. Alright, now what we should be able to do is we're going to go ahead and do for let I equals 0, I is less than max digits dot length plus plus I, and then we'll go ahead and keep track of the result array right here. And we will go ahead and do this. If min digits at index I is not undefined, that, or rather, if I is greater than or equal to min digits style, or rather, if I is less than min digits style length, we will go ahead and do results.push max digits at index I plus min digits at index I here. Otherwise, we'll just do result.push max digits at index I here. And that should do it for that. Let's first return our result array here. And we're going to go ahead and do a console.log down here. We add 2 and 11. Do a silly addition of our 2 and 11 here. Let's go ahead and run that through Node here. Warm up to 14, or rather to 14. And we get to the digits 3 and 1. Those digits should actually be reversed, so instead of push, we're going to do an unshift here. And we get the digits 1 and 3. What if we did 0 and 1? And we get 1 in that array here. So let's have a look at some. Let's have a look at this one here. 16 and 18. We expect to see 14 and 2, and that's actually not what we wanted to see here. Because I think actually we need to reverse these here. And we get 2 and 14. Now, let's revisit that other test here with the 2 and 11. We still get the 1 and 3. Good. Let's have a look at this one right here, 26 and 39. Let's see, that looks like we get 5, 15. Alright, I think we're almost done here. What we now need to do is, we're going to run parse in, and we're going to pass into that to return a result.join. We're going to join these numbers together with a blank string separator here. And I think it should be working correctly now. Let's go ahead and punch this into Codewars to see what this looks like here. Run the tests. We've got a problem. What's going on? Selected 103 to equal 103. Hmm. 122 and 81. We seem to be tripping on here now. And why are we tripping up on this one here? Let's go ahead and return our result array here. 10 and 3. Ah, okay. Yeah. Let's do a console.log here. Max digits and min digits here. That's not right. Because we had a little bit of an error in our if statement up here. We were comparing the length of the first char's array to the second char's array itself and not its length. And now we get the correct array here. 1, 10, and 3. Alright, let's go ahead and uncomment that here. And we get the proper answer of 1,103 here. Let's try some of these big addition tests before we decide to punch this into Codewars. How about 49,999? Pretty snazzy with that. Let's go ahead and punch this into Codewars to see what this looks like here. And we are good on that. Finally, we are finding the product of the main diagonal of a square matrix. Alright, the goal of this kata is, given a list of rows in a square matrix, find the product of that matrix's main diagonal. Alright, let's go ahead and get started with this one. First, I'm going to do the console.log here. I'm going to copy this. I'm going to do console.log. I'm going to paste this right here. As you can see, we have a 3x3 matrix here. And what we need to do, we need to get the numbers, the elements in the main diagonal of that matrix, which would be the line running down from the top left to the bottom right. And then we need to get the product of those numbers. So, let's go ahead and get started with that here. Console.log, or rather, const main diagonal product. We're going to set that equal, and we're going to take a matrix as its lone argument here. Now, we can safely assume that this is going to be a square matrix with the same number of rows and columns. So what we should be able to do here is, we're going to keep track of a result string here, or rather a result number. We're going to return result here. And since we're doing a multiplication here, we actually need to set this to 1. And what we'll do is, for let I equal 0, I is less than matrix.length plus I here. And then we will go ahead and do this here. Result times equals matrix at column I, or rather row I think, column I right here. And that should work. Let's go ahead and test this out here. Node, warm-up, square, matrix, diagonal, and we get the answer of 45, which is what we want to see. Alright, let's go ahead and try punching this into Codewars to see what this looks like. Let's hit test. And we are good on that. Some of these warm-up katas were a little bit more difficult than I thought they would be, but I'm glad I got through them. That concludes today's warm-up segment. I will see you in the next kata. Continuing with the theme of square matrix diagonals, here we have another square matrix right here. And the goal of this kata is to get a couple of averages from this matrix. First, we need the average of all of the positive integers that are in the printable, the main diagonal of this matrix right here, in the columns with an odd index. So, basically, this 0, and this 8 right here, for instance. And then also, we need the absolute value of the average of all of the negative numbers in the secondary diagonal of this matrix. The secondary diagonal goes from bottom up, from left to right here. So this 11, 4, negative 4, and so on and so forth. And in this case, we need the elements in the even indices here. So the minus 11, minus 4, this 7, I think, here. But that is a positive, and this 1 right here, which is also a positive, so we ignore that here. And we need the average of all, the absolute value, the average of all the negative numbers in this diagonal up here. Alright, let's go ahead and give this one a try here. Our function signature here, let me scroll down here. Average diagonals, that's AVG diags. And we have our matrix right here. And what we are going to go ahead and do, first let's go ahead and get the average of all of the positive numbers in our main diagonal in the odd indexed columns here. I think actually we can kill a couple birds with one stone here. First, what we'll go ahead and do is I think we'll knock this down with a single for loop here. Now, since we're dealing with a square matrix here, the number of rows and the number of columns here will be exactly the same. So, for actually set up a couple of arrays here. Odd positives. And another one called even negatives. And what we'll do here is, we're going to do for let I equals 0, I is less than matrix.length plus I. First, we'll start at we'll go ahead and get the main diagonal. Main diag, we'll set that equal to matrix at index I at I here. And then we'll go ahead and get the second diagonal. Set that equal to matrix at index matrix.length minus 1 minus I here. And then that at index 0. Let's go ahead and console.log these two here just to see what they look like here. I'm gonna go ahead and run this through Node here. Node process single or square matrix. I'm gonna open up this terminal here a little bit. And as you can see, this spits out all the elements in the main diagonal and then in the secondary diagonal. It should be going upward. And I think we got a little bit of a problem here. Because we want index I, not index 0. Let's try that again here. Yeah, we get the minus 11, 4, minus 4, 0, 7, 8, and 1. Alright. What we should be able to do from here is, if our I is an odd number and our main diagonal is greater than 0, or greater than or equal to 0, then we will go ahead and do odd positives, and we will add this main diagonal to that array here. Otherwise, if I is an even number and the secondary diagonal is less than 0, we will do even negatives, not push second diag. Alright, let's go ahead and console.log those two arrays here on positives, even negatives. And let's go back into our terminal here and run that through Node to see what that looks like. Alright, we get to our odd positives here, which is 0, 0, and 8. And our even negatives, which is minus 11 and minus 4. And that is what we want to see here. Now, what we will do from here, our Kata calls for us to return an array here, a pair. And what this pair is going to contain is, for our first element here, we are going to want the average of all of the positive numbers that are in the principal diagonal. In other words, the contents of the odd positives array. So, we'll do odd positives. We'll do reduce val plus a val divided by odd positives dot length. And that will be the first element of that pair to be returned. Now, for the second element, we need the absolute value of the average of all the negative numbers in the secondary diagonal and in the columns with even index. So, what I think we'll go ahead and do, we'll do even negatives, reduce val, do the very same here, even negatives dot length. Now, we will need the absolute value of this, so we'll just wrap that in a call to math.abs here. Oops. Alright, let's go ahead and test this out here. And, oh, right, we do need these rounded to the closest integer. So, we're just gonna wrap these up in a called a math.round here. I'm gonna do just that here. And we get 3 and 7, which is not what we want to see here. I think our ABS actually needs to be before the round here. And we get to 3 and 8 as our answer here, which is what we want to see. Let's have a look at some of these tests down here. Yeah, I think we'll go ahead and punch this into Codewars to see what this looks like. Let me bring this terminal down here. Copy this in. I'm going to hit test. And we got a little bit of a problem. Reduce an empty array with no initial value. If one of the diagonals has no elements fulfilling the requirements described above, return -1. So, if odd positives, not length, is 0, or even negatives, or, whoops, dot length is equal to 0, then we'll return -1 here. Alright, let's go ahead and punch this into Codewars here. Still a problem.
-1. Now let's go ahead and cancel dot log into that odd positives and even negatives here. And then we'll also go ahead and cancel dot log the matrix as well. Let's look at output again.
Okay. Maybe the function should have been a little more clearer of that here, but what we actually need to do, odd positives, length is greater than 0. And then even negatives, length is greater than 0. So let's go ahead and try punching this into Codewars to see what this looks like here. Yep, it's passing now. Let's go ahead and hit attempt. And we are good. I will see you in the next kata. The one gripe I have with this particular kata is a little bit of an oversight in the kata instructions, where if it says if one of the diagonals did not have any elements in that resulting array that fell into that range or criteria, that the function should return -1. However, the test expected that -1 to instead be placed into the resulting pair. So instead of the function returning -1, the function would return -1 and so in the pair if, for example, the odd positives array did not have any elements in it that fit the criterion. Oh look, it is our familiar square matrix again. This time we are going to be focusing on the contour of this matrix. The contour of a matrix is comprised of all of the outermost elements of that matrix. In other words, it's made of the elements of the first row, the elements of the last column, excluding the first one, the elements of the last row, excluding the last one, and then finally, the ones on the first column, excluding the first and the last one. The goal of this kata is to do the following. We have to select the elements of this matrice's contour that are in a given range, A and B, inclusively, in order to find the element or elements of that contour with the highest occurrence frequency. We have to give an array with the maximum amount of occurrences followed by the wanted value, or in the case of having 2 or more encountered values, in increasing order. Alright, for example, we're given this array right here. We have seen this in the last couple katas here. The contour of that matrix here is, let me go ahead and copy this over here. Contour is made up of these numbers right here, as you can see right here. And given an A and B of -1 and +7 respectively, the elements in that range is this right here. Let me go ahead and, as you can see right here, the number 4 has the highest occurrence frequency, and it occurs 3 times in this range right here. 1, 2, and 3 right here. So this kata would output this right here. We have 3 occurrences of the number 4 right here. Alright, let's go ahead and give this one a go here. I'm going to comment all this out here. And what we are going to go ahead and do, we're going to do const contour mode. And we're going to have our matrix right here. We are going to have our mid-range and our lower bound and our upper bound right here. Now, first what we will need to do, in the particular case of this kata, the given matrix does not have to be a square matrix. It can have a differing number of rows and columns. So we actually need to take into account how many rows and how many columns are in this matrix right here. And what we will go ahead and do in so doing is, I think we'll go ahead and do const column count, column size, and set that equal to matrix dot length. And then we'll do const row size. We'll set that equal to matrix at element index 0 dot length. Now, we need to programmatically determine the contour of our matrix right here. And I would like to remind our viewers here that this kata bears the optimization tag right here. So we will also need to take that performance into account here. So what we'll go ahead and do, I think we will go ahead and iterate from for let I equal 0, I is less, I think, than row size, I think. Okay, we got that wrong here. Row size is actually going to be matrix.length. And then const column size will be matrix at index 0.length. Anyway, what we'll go ahead and do is, for let I equals 0, I is less than column size plus I here. And what we'll go ahead and do, I think we'll try to kill 4 different birds, maybe 6 different birds with 1 stone here. And we'll go ahead and set up an array with our ranged contour. Set that to an empty array right here for now. I think the push method can take more than one argument. Yeah. So what we'll go ahead and do. Might be a little bit easier if I did the row size instead. Yeah, I think we will do just that. And then I think what we'll do, const side, we'll create an array here called side. And then what we'll do, if I is equal to 0 or I is equal to matrix.length, we'll go ahead and push everything into that side right here. Or rather, I might want to make a slice of that. Yeah, I think that's what we'll go ahead and do. So let's side here. Set if I is equal to 0 or I is equal to matrix.length minus 1. We'll do side equals matrix at I dot slice. I actually want to do a filter here. Yeah, I have a new idea. Ranged contour. Dot push. And then we'll go ahead and push into this the elements of a filtered array. So dot dot dot. Matrix at index I dot filter, and we'll pass into it a predicate function here, and we'll return true if number is greater than or equal to the lower bound and number is less than or equal to the upper bound. Otherwise, what we'll go ahead and do, we'll do ranged contour, push into it, an array containing matrix at index I at index 0, matrix at index I at index matrix I dot length minus 1, and we'll run that through the we'll try running that through the filter method as well to get the ranged contour. And I think that might just be all there is to it. You know what? Actually, why go to that trouble when we can just do column size? Yeah. Why go to that trouble when we can just do column size right here? Alright, let's go ahead and console.log that ranged contour here to see what it looks like. And we'll go ahead and feed that into node to see that looks like here. Nope, wrong. Kata, node, matrix contour. I actually do need to call that function here. Console.log. I think it's contour mode, and we'll pass in that familiar matrix here. We get empty arrays here, and we do not want that because we did not pass in our A and B here, our lower bound and upper bound. Let's do that here. Pass in -1 and 7 here. We actually need to spread that array out here. And it looks like we had a contour 1, 3, 5, 5, 1, 2, 4, 7, -1, 6, 3, 4, 6, and 4. Alright, let's go ahead and 1, 3, 5, 5. 1, 2, 4. Yeah, it doesn't look like it's in the right order, the same order as the Kata instructions show, but it does seem that we are getting the right numbers here. 1, 3, 5, 5, 1.
7. Yeah, 1, 2. 4. 7. -1. 6. 3. 4.
Yeah, I think this is right here. This is a 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yep, 14 elements. I think this is right here. So what we're going to go ahead and do, I think we'll also keep track of an object here. Detailing each of the occurrences of our objects here, or each of the occurrences of the elements here in this ranged contour here. I think we'll do just that here. Might want to consider doing remember, we gotta keep performance in mind here too. I just don't know how performant this loop here is, because ultimately we're dealing with 3 loops here. And I think what we'll go ahead and do, maybe instead of keeping track of a whole array here, I have another idea. Let me go ahead and comment this out here. Let's keep track of an object. We'll call it occurrences. And then if no, that would still involve the use of another for loop here. No, I think we'll roll with this then here. Whoops. Anything less? Right. I think we'll do a second for loop down here. For const element of ranged contour, what we'll go ahead and do is an element occurrences element plus plus, or I think that'll work. Let's see what that looks like here. Let's go ahead and console.log the occurrences now. Alright, we're almost there. Okay. Finally, what we need to do is determine which element or elements occurs the most in this ranged contour. Aha. Maybe 4. Alright, I think what we'll go ahead and do, const max occurrences, we'll set that equal to math.max object.values, passing in our occurrences here. And then we'll do const frequent, most frequent. We'll do an array right here. Object.keys, occurrences. We'll run that through the filter method. Or rather, pass in the number. And then occurrences at a number is equal to max occurrences. And then we should just be able to return our pair here. Max occurrences. And then most frequent. And that should be all there is to it. Let's run this here, and we get 3 and 4. And we get 3 and 4. This should be a number. That should be a number. Object keys occurrences. Let's map that to parse int freq. And we get 3 and 4 as a result. I think we may well be onto something here. Alright, let's see what this looks like punched into Codewars here. Alright. Oh, that's interesting. Alright, let's grab this array right here. Or rather, let's grab this matrix right here. And let's run that locally here. Console.log contour mode. Pass this in. Pass in 0, pass in 5. We have 4, 1, and 2. But the test, for whatever reason, expects an empty array. Now, let's have another look at the instructions here. In the case that all the values have the same frequency, the output will be an empty array. Okay, what we'll do then, we'll do const elements occurred. We'll do that set that equal to object.keys occurrences. Then we'll replace this with elements occurred. And then, if elements occurred dot length is equal to max occurrences dot length, then at this point we ought to know that all the values have the same frequency, so we'll return that empty array right here. Let's run that again, and we're still getting an incorrect return here. Alright, let's go ahead and do some console.logs here. Console.log elements occurred. We have 1 and 2. Ah, right. Most frequent. Alright, let's go ahead and punch this into Codewars now. to see what this looks like. Those tests pass. Now, there's the matter of the performance aspect. Let's see what happens when we hit attempt. We got a mood because we got a little problem here. Huh. Yeah, aren't we a little bit of a stickler here? Huh. Give them the right elements. But it looks like the test wants those elements in ascending order. I did not catch that. Yup, Kata instructions called for that in ascending order. So we'll go ahead and append to this map here. Sort. Alright, let's go ahead and copy this over here. I think that's the end of my map call here. Let's hit attempt. And we are good. Now, what I could have done in this Kata solution to make things quite a bit more performant was to use a clever combination of the spread syntax and the array object slice and map methods to be able to extract all of the outermost elements of our matrix to form the contour. And in so doing, I could have saved at least one loop and all of the calls that I did to filter. Here's what I should have done. First, I would use the slice method to slice out all but the first and last elements of the top part of the matrix. Then use the map method to pull all of to iterate through all of the rows of the matrix and pull the last elements from each of the rows. Then use the slice method on the last row of the matrix to pull all but the first and last elements of that row, and then use the map method to pull all of the first elements from each of the rows. And in so doing, I probably would have saved at least one for loop here and made my solution a little more performant. We are continuing once again with the theme of square matrix diagonals. A square matrix is considered upper triangular if all the entries below the main diagonal are 0. Similarly, a square matrix is considered lower triangular if all of the entries above the main diagonal are set to 0. Given a square matrix n by n, where n is greater than 1, the goal of this kata is to determine if that matrix is upper triangular or lower triangular. We will need to write two functions here. Both of these functions will return true if the matrix is upper triangular or lower triangular, respectively. Let's go ahead and get started with this one. First, we'll focus with the upper triangular function. Const upper triangular. We'll have our matrix as the lone argument here. And what we will do is I think what we do I just imagine what we'll do for let I equals 0, I is or rather I equals 1, I is less than matrix dot length. plus I. Well, it's a square matrix, so it's going to have the same number of rows and columns. So unlike the previous kata, we won't have to concern ourselves with the number of rows and columns. And so we'll just use the matrix.length right here. And then actually, we need to start with 0 here. I think we need to iterate downward now too. For let j equals 0, or rather 1 plus I. J is less than matrix.length plus j here. Let's go ahead and grab these here. Do a couple console.logs here. Just gonna paste that here. Wrap these up in a couple console.logs here. Oh, oops. Come on. Let's go ahead and alright, let's go ahead and console.log matrix and I and j here. And let's do node triangular matrices. I don't think I was expecting that result here. Let's do I and j here as well. 0, 0. Or rather, let's do j and I then. I think that was the desired result here. Okay. So, if matrix at j and I is not equal to 0, then we return false here. Otherwise, we make it to the end of this nested for loop here. Without returning false, we'll return true here. Both return false, which is not right here. Let's go ahead and see what's going on here. Do a console.log j I matrix at j at I here. Oh, right. Is not equal to 0. Alright. We get the proper returns of true and false here. Alright, let's go ahead and focus on the lower triangular function now. Const lower triangular. Once again, we'll have our matrix as the lone argument here. And what we'll go ahead and do. Well, we just flip the process here. Instead of I, have a J here. I'm going to go ahead and console.log that. I, J, matrix and I and J here, right? Alright, let's go ahead and first comment these out here. And let's go ahead and grab these calls, the lower triangular here. We'll wrap these up in console.logs. And we'll test that out here. We get true and false. Alright, 1 0 1 1. Alright, I think if I'm not mistaken, we're right. Let's have a look at some of these tests down here. I'm gonna copy this over here. And paste that here. Replace these with console.log. Alright, I think we are ready to punch this into Codewars to see what this looks like. Let's get rid of this console.log right here. Hit copy, paste this here, run the tests. Let's hit attempt. And we are good. Now, in hindsight, this was a Kata solution in which, in terms of creating and populating the array to be returned, I wasn't quite thinking clearly. Instead of pre-populating the array, what I could have done was, in the outermost for loop, I would have created the new matrix row, and then added the appropriate elements from the initial matrix to create the transposed array, and then pushed that array into that particular array that I... To transpose a matrix is to interchange the rows and columns of that matrix along its main diagonal. The goal of this kata is to write a prototype transpose for the array object in JavaScript to transpose a matrix like what you see in this image right here. Pay close mind to this image. I'll give you a few moments here to let this play out here. Alright, let's go ahead and get started with this one right here. We are implementing this function as a prototype of the array object. So we'll do this. Array.prototype.transpose. We'll set that equal to a function here. Since we're using a prototype here, we have to use the ES5 function syntax here. And we are going to grab this right here into a console.log. And our goal will be to transpose this. So, I think... One, four... Alright, what we'll go ahead and do. First, we'll go ahead and console.log this here. Just to see what that looks like here. Node matrix.transpose. Alright. Alright. Console.log new array 3.fill. Yeah, that's one way to do it. Okay. I think we get the row count and then the column count. Const row count equals this the length. Const column count equals this at index 0 dot length. And then what we should be able to do is const result equals new array of length column count dot fill new arrays row count dot fill 0. And we'll just go ahead and return that result for the moment here. Alright. 1, 4, 2, 5, 3, 6. Or let I equals 0, I is less than column count plus I, or let j equals 0, j is less than row count plus I. We'll do result at I at j we'll set that equal to this j at I, right? I wouldn't think so. Let's do actually a console.log of that here. Let's extend our terminal here. Whoops. One, 4, 2, 5, 3, 6. Okay, what we should be able to do now is result at I at j I don't think that I somehow don't think that was what we wanted to see here. Do a console.log of the result here.
Console.log result at I, or rather this at j, this at I here. Clear a terminal here. 2, 5, 3, 6. Result at I at j. So, what we took? Results at I at j. We set it to this at j at I.
Oh, wait a minute. I think I know where we're going wrong here. I just remembered something. Console.log the result. Yeah, okay. What I'm probably gonna need to do then is for okay, I think we got it right here. Let's go ahead and get rid of these console.logs here. Alright, let's go ahead and punch this into Codewars to see what this looks like here. Should test for something. Oh, no tests. Yeah, we're just gonna have to hit attempt and we have a problem. Cannot read property length of undefined. Just gonna do a console.log this up here. Empty array. Bunch of okay, so if this dot length is equal to 0, turn an empty array here, I think. Alright, let's go ahead and punch this into Codewars and see how many of the errors that wipes out. Bring up this console.log this here. Okay. If this at index 0 dot length is equal to 0, then we'll return an array containing an empty array here. Alright, let's punch this into Codewars to see what this looks like here. And And we are good. Now this is a Kata solution which, in terms particularly of creating the array to be returned, I wasn't quite thinking clearly. In my Kata solution, I went ahead and pre-populated the array with the proper columns and rows for the transposed matrix. What I could have done instead was, I would not have populated the array, but I would have created that array. And then the outer for loop, I would have created a new array for the row, populating that row with the proper elements needed to transpose the array, and then push that row into the result array to be returned, repeating for the number of rows. The goal of this kata is to write a function that accepts a square matrix and returns the determinant of that matrix. Let's go ahead and get started with this one here. Alright, let's go ahead and write this down. Constant determinant. We'll have our matrix right here. Now, let's go ahead and tackle these simpler solutions here. Now, in this particular case, we're dealing with square matrices here, so the number of rows and columns will be exactly the same. So what we'll do is, if matrix.length is equal to 1, if this is a 1 by 1 square matrix, we'll go ahead and return matrix 0, 0. Because the lone element in a 1 by 1 matrix is its determinant. Otherwise, if our matrix's length is 2, then we can resolve that in a very simple manner here. We take A times D minus B times C, where A is element 0, 0, B is element 0, 1, C is element 1, 0, and D is element 1, 1. So we'll do this. We'll return the following. Matrix at 0, 0 times matrix at 1, 1. I'm going to go ahead and encapsulate that in parentheses here. Minus matrix at 0 and 1 times matrix at 1 and 0 here. Alright, those are the simpler edge cases down. Now we gotta focus on the larger matrices here. And what we'll go ahead and do is we need to get the minor matrices from this matrix here. The determinant of an n by n size matrix is calculated by reducing the problem to the calculation of the determinants of n matrices of n minus 1 by n minus 1 size. For the case of a 3 by 3 matrix, the determinant would be the minor matrices of these 3 by 3 matrix would be the 3 2 by 2 matrices created by crossing out the row and column in which the element A occurs. Okay. Alright, we need to create some minor matrices here. So what we'll go ahead and do, I think it might be helpful if we had a helper function for this one. Let's get minor matrices and pass in our matrix here. And we'll do this right here. Const minor matrices equals get minor matrices passing in our matrix. And in this helper function, what I think we'll go ahead and do, I think we'll do for let I, we'll have a result array here. For let I equals 0, I is less than matrix.length. Remember, square matrices plus plus I. And what we will go ahead and do,
Okay. matrix here. Constant minor matrix dimension count, matrix dot length -1. I think one might need a nested for loop for this one. I don't know. Yeah, okay, we'll go ahead and populate to that result matrix right now. Uh-huh. Then we push into a new array. Right, okay.
Alright, first we need to go ahead and populate our result array with blank arrays here. And then... No. Okay. That's minor matrix. I think we'll do 4, let j equals 0, j equals less than matrix dot length plus j. If j is equal to I, then continue. No. Okay, I need to think of this very closely here. Let's column, I think. For let I equals 0, I is less than matrix dot length plus I. Const minor matrix. Set that equal to an empty array for now. Then we need to get the row here. And then for let j equals 1, j is less than matrix dot length plus j. And then for let k equals 0, k is less than matrix dot length plus k. And then if k is equal to I, then we get continue. Otherwise, we'll do minor matrix dot push into it an empty array. And then minor matrix dot push, or rather at minor matrix dot length -1 dot push. We'll push into it matrix at j at k. And then we'll go ahead and console.log that for now. Oops. I want to do that at the end of the outer for loop here. And that's not going to return anything for now. Let's go ahead and grab this matrix right here. I'm going to do a console.log determinant. We're passing this matrix right here. Let's feed this in. We have a little bit of a problem here. Else if. Alright, let's go ahead and do node matrix determinant. I'm pretty sure that is not the result I was expecting here. Okay, let's debug what's going on here. Let's count the minor matrix. Let J and that should correspond to the second row here. We start from the second row. Go to the length of the matrix. Push into that an empty array here. And we go from K0, K matrix.length. K is, oh, right, K is equal to I. Then we continue. Alright, it's 2 minus 2 minus 1. 3 and 4. Minus, yeah, 1 minus 1, 1 and 4. 1 minus 2, 1 and 3. And that should be our minor matrices here. Albeit it looks like we got them in reverse here. Let's go ahead and expand on this and bring in a 5-dimensional matrix here. Minus 1, 4, 3. 1, 3, 4, 2, 5. 1. Minus 2, minus 5, 3, 2, 4. And 5, 4, 3, 2, and 1. Let's see what this one does here. 2, 1, 4, 3, 3, 4, 2, 5, minus 5, 3, 2, 4, and 4, 3, 2, 1. And then the second one, we have 1, minus 1, 4, 3, 1, 4, 2, 5, minus 2, 3, 2, 4, and then 5, 3, 2, 1. Good. For the third one, we have minus 1, 1, minus 2, 4, 3, 1, 3, 2, 5, minus 2, minus 5, 2, 4, 5, 4, 2, 1. Good. The fourth one, we have minus 1, 1, minus 2, minus 1, 4, or 3, 1, 3, 4, 5, minus 2, minus 5, 3, 4, and 5, 4, 3, 1. Good. And finally, we have it seems we are successfully getting the minor matrices here, and that is what we want to see. Alright, now what we need to do we're going to create an array up here for our minor matrices here, and we're going to push, or rather, we are going to unshift that minor matrix into our return array here, which will return down here. Alright, that's one major piece of the puzzle down right there. Or rather... Gotcha. Okay. Well... Alright. We just need to push them in instead of unshift them. Okay, with that all said and done, let's go ahead and work on the next part of this. And I think that is going to be the... You're going to be dealing with the return of a reduce method call here. So, what we're going to go ahead and do... We're going to return minor matrices dot reduce. We're going to have our accumulator here, our value, and we need the index here as well. And what we are going to have to do is... Alright, we start with a minus here, and we have a plus here, and then we have a minus. Note the alternation of the signs here. Since we're dealing with a multiplication here, I think we gotta start our word. Yeah. And then we start with an addition and then a subtraction. So if index is an even number, then we'll return ec plus. Now the value here, yeah, we actually are gonna need the matrix, the elements in the first row of our matrix here. So value times, and we're gonna utilize a little recursion here. So determinant, we're gonna call our determinant function again. We're gonna pass in the minor matrices array at index here. The index given by the third parameter of our predicate function here. And then else if index modulo 2, if index is an odd number, we will return ec minus a value times determinant minor matrices at index here. I think this will work. Let's try it. We get the value of 412 here. Alright, let's have a look at some of our tests here and see if this falls in line here. Whoops. Copy. I'm going to go ahead and paste this in here. And we get the determinant of minus 20, and that is actually what we want to see. Alright, let's try another matrix here. 1, 3, and 2, 5. Whoops. Right. 1, 3, 2, 5. And we get the determinant of, minus. And we get the determinant of -1, which is what we want to see. Alright, I think I'm ready to punch this into Codewars to see how the other tests respond to this solution here. Now, this being a 4Q kata, I wouldn't be surprised if I had to take performance into account here as well. Let's hit attempt. It looks like I won't have to take performance into account here, or maybe this is performant enough because we are good. Now, here's a tip on how to get a minor matrix from a larger matrix in JavaScript. It's more concise and probably more performant than my own kata solution here. First, you're going to have a matrix and an index. That index is the column of the larger matrix that you're going to ignore when you're creating the minor matrix. First, you take the matrix and run it through the slice method to get all but the first row of that matrix. Now, you're going to run each of the rows, the array of rows, through the met method here. So for each row, you're going to return using a spread syntax all of the elements from that row excluding the index that you pass in. So you're going to use the spread syntax to slice the row from 0 to the index, and then the spread syntax again, the slice from that index to the end of that row. And that is a more concise way to get a minor matrix from a larger matrix. I'm going to have to keep that in mind. And that is going to do it for today's episode of Versus Codewars. I learned a lot today, and I hope you did too. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. As always, if you think there is anything I can do to improve on my code for the better, feel free to drop a suggestion in the comment section below. Also, if you are a kata author on Codewars, and you would like to share your authored katas with me, feel free to drop links to those katas in the comment section below, and you might see me take those katas on in a future episode of Versus Codewars. I hope you have a wonderful and safe day today, and I will see you on the next episode of Versus Codewars.